Well, every other time in mathematics when you've learned about a new kind of number, you've immediately learned, or learn as soon as you can, you've learned how to add, subtract, multiply, and divide. Well, we now know how to add and subtract polynomials. It's time to learn how to multiply them. And perhaps even more importantly, how to factor them, how to undo multiplication. Not just dividing. With polynomials, undoing division, undoing multiplication really means factoring more than it does dividing. In this sense, then, normally you would see multiplication and division together, but factoring is a much better answer, a much better correspondent to multiplying than division is. And factoring is one of the crucial skills that we use to solve equations when they have polynomials involved. So it's going to be a very important skill throughout your math career from now on. Whenever you're dealing with polynomials and certain algebraic concepts, factoring is going to be a crucial skill everyone will expect you to have. This is an example of the kind of thing you're going to be doing in this section in your textbooks or with the problems that your teacher assigns to you, where you'll need to apply an old friend to do something new. If you look at this expression and think about it, if the x wasn't there next to the 3, what does this look like that we've already seen in our algebra work? Well, you probably hit on it. It looks like the distributive property. And in fact, the distributive property is at the core of everything we're going to do involving multiplying polynomials and factoring. So get ready to use the distributive property like you've never used it before. One thing you're going to see a lot of in your future in mathematics work is that multiplication finds one of its best models in finding the areas of rectangles. Here in front of you, you see my attempt to draw a rectangle. Again, I'd love for ShowMe to install a straight line tool sometime, but regardless, I think Poliquin art will get us by here. I've drawn a rectangle that matches the expression we have on the screen. Its height is 3x. Its length, or its base, is 4x plus 2. And I've broken this big rectangle up into a bunch of squares and smaller rectangles so that we can calculate the area of each little square or rectangle and then use that to find the product above. So, looking at our big rectangle, let's start filling in areas for each of our four-sided figures. Starting in the upper left-hand corner, x times x is x squared. And in fact, every single one of those squares, 4 across and 3 down, is going to have an area of x squared, because both its length and its width are x. So x squared across that first row, and the second row, and the third row. Each of these squares has to have an area of x squared. Using the same principle, but the different numbers, these little rectangles off to the right that don't have values in them yet, what will their areas be? Well, they have a length or a base of 1 and a width or a height of x. 1 times x is x. And again, each of those is going to have an area of x. Well, how does this help us get the answer? Well, let's add them all up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x squareds. And we have 1, 2, 3, 4, 5, 6. We have 6 x's. And that's the answer. That's the product. 3x times the quantity 4x plus 2 is equal to 12x squared plus 6x. Now, that may seem like an awful lot of work. I have very good news for you. You don't have to make a big picture like that every time. And indeed, when there are negatives involved, that'll get pretty complicated if you aren't very good at managing details. Fortunately, we don't have to be good at managing details. We have to know how to multiply expressions that involve powers, and we need to know how to use the distributive property effectively. So what does the distributive property say about a problem like this one? Well, what it says is that every single term, every addend inside the parentheses has to be multiplied by the factor on the outside. So we've got to take 3x times 4x. Well, that's 12x squared. Then we have to take 3x times 2, and that's 6x. That's much easier than drawing the picture. But I wanted to make sure you see the picture because this won't be the last time that somebody tries to show you how to multiply numbers by modeling them as length and width of a rectangle. It'll happen over and over again. So let's apply that same line of reasoning and methodology to a more complicated problem. Here, as I've said, we're supposed to be using the distributive property to make sure each addend inside the parentheses is multiplied by 3b. Well, what is 3b times 6b squared? 3 times 6 is 18, and b times b squared, b is actually b to the first. B to the first times b squared is b cubed. Remember that when you multiply powers of the same base, you simply add the exponents. Okay, what's 3b times negative b? Well, first of all, never forget that's actually negative 1b, and it's negative 1b to the first power. 3 times negative 1 is negative 3. B to the first times b to the first is b squared. Finally, take 3b to the first times 7. Well, 7 times 3 is 21. There is no b there. Oh, but wait, there is. There's a b, but its power is 0. That 0 is supposed to be inside the parentheses. Anyway, 3 times 7 is 21. B to the first times b to the 0 is b to the first, or just b. So that's the methodology you're supposed to use. Notice that I was rather meticulous and detail-oriented about some of those things. As you get more confident, you may find yourself skipping those steps. I don't usually write all that out when I do my work. However, especially when you're just beginning, it is really important to make sure that you are careful with the details. Polynomials aren't terribly hard to work with as long as you're not overconfident and as long as you do have an eye for details. Let's try another one, this time involving a negative factor on the outside. The same process applies we just showed. Negative 6h times 4h squared means you're going to take negative 6 times 4, you get negative 24, and h to the first times h squared is h cubed. Then take negative 6h times negative 7h. Remember that this is an addend, you're adding a negative 7. Negative 6 times negative 7, positive 42. And h to the first times h to the first is h squared. Finally, negative 6h times 2. Well, negative 6 times 2 is negative 12. And then h to the first times the invisible h to the 0 is h to the first, or just h. So that's the process of multiplying monomials by polynomials. That's as far as we'll take it in this section. But in the next section, and the sections to come, we're going to work very hard at both multiplying and factoring other kinds of situations, where you're multiplying and factoring polynomials with more than just one term. We have some factoring, however, that we can do right now. If we can multiply one factor into a polynomial, surely we can factor one out if that's possible. The trick to that, of course, is looking carefully at a polynomial and deciding if there is a common factor that can be factored out. Of course, if there is a factor that can be factored out, it needs to be the greatest common factor of the terms. So when you see a polynomial like the one that's on the screen right now, you're looking for the GCF, and you want to identify it quickly and correctly every time. The first step in any factoring process is to discover the greatest common factor if there is one. There will be plenty of cases where there isn't one. That is, there'll be plenty of cases where all the terms are relatively prime to each other. But that doesn't mean there won't be things you can factor out in other ways. It just means there won't be a greatest common factor to factor out. Again, if there is a greatest common factor to be factored out of a polynomial, if you've been assigned to factor it, the first thing you should do is factor that GCF out. Well, is there a GCF here? Well, there is at least one element to it, and that's because 6 and 3 certainly have a common factor. The GCF of 6 and 3 is 3. But v to the fifth and v cubed also have a greatest common factor. v cubed is a factor of v to the fifth, and of course it's a factor of itself. So v cubed is part of that greatest common factor. So if you have a situation like this where you have two terms that both include powers of the same variable, whichever is the least power that occurs in every term, and v cubed does occur within v to the fifth, whichever is the term of the least degree that occurs in all the terms of the polynomial, that factor will be part of your GCF. So now that we've identified the GCF, identified that 3v cubed is a factor of both terms, let's factor it out. Let's rewrite this product as a product. Well, the GCF is going to be part of our answer every time that we factor it out. Now we have to divide. We're undoing multiplication, so that shouldn't come as a shock. First, take 6 divided by 3, and that's 2. Then take v to the fifth divided by v cubed. Well, when you're dividing powers at the same base, you subtract the exponents. 5 minus 3 is 2. We do the same thing with 3v cubed. 3 divided by 3 is 1. V cubed divided by v cubed is also 1, so 1 is the quotient. Now, if you ever have a doubt about your correctness on these problems, you can quickly check your work. You should never miss one of these because you should always know before you ever hand it in to the teacher whether you've got the answer. How would you know that? Well, you can do what we were just doing a moment ago and multiply this back out to see if it works. 3v cubed times 2v squared, 3 times 2 is 6, v cubed times v squared is v to the fifth, and 3v cubed times 1 is, of course, 3v cubed. And that is what we started with, so we do have the right factorization. This is a crucial skill, and again, I have to emphasize, every time someone gives you an instruction to factor a polynomial, the first thing you should look for, before you look for anything else, is to see if there's a greatest common factor that you can factor out of the polynomial before you employ any of the other techniques you're going to learn in your units about polynomials. So here's another one. Let's practice our skills. We're told to factor this. What's the GCF? Well, the GCF of 4 and 16 is 4. But t squared and t to the 0 don't have any factors in common other than 1, and that's not going to be terribly interesting. So when we factor this, all we're going to factor out is a 4. Well, 4 divided by 4 is 1. T squared divided... Well, wait a minute. There's no t with our GCF. There's no t there. Yes, there is. But it's t to the 0. T squared divided by t to the 0, we should subtract those exponents. 2 minus 0 is 2. So t squared is still going to be there. But 4 divided by 4 was 1. Our first term inside the parentheses is going to be 1t squared, or just t squared. The other term is going to be negative 16. Remember, we're adding a negative 16. Negative 16 divided by 4 is negative 4. And is that the correct factorization? It's easy to check. Multiply it back out. 4 times t squared, 4t squared. 4 times negative 4, negative 16. That will do. Let's take a look at this one. What's the GCF of all these terms? Well, our coefficients are 15, negative 5, and negative 10. What do 15, negative 5, and negative 10 all have in common? They're all multiples of 5. So we're going to divide a 5 out of everything. Is there a common factor for b cubed, b squared, and b? Yes, there is. Remember, that's b to the first. And b to the first is part of b squared, and it's part of b cubed. And of course, it's a factor of itself. So the GCF here is 5b, which remember is 5b to the first when you go to do your dividing. So we have 15 divided by 5, that's 3. We have b cubed divided by b to the first, that's b squared. We have negative 5 divided by 5, which is negative 1. And b squared divided by b to the first is just b, so that'll be a negative b. Then we have negative 10 divided by 5, that's negative 2. b to the first divided by b to the first is b to the 0, which is 1, which we don't need to write. So that's our division. Notice that I made a mistake here. I forgot to write my GCF first. Let's put that back in. That's bad form on my part. Please remember, when you factor, you have to write everything, because when you go back to check your work, you should be able to regenerate the beginning polynomial. Let's see if that works out here. 5b times 3b squared, 15b cubed. 5b times negative b, negative 5b squared, and 5b times negative 2, negative 10b. And that is indeed what we started with. So this is the correct factorization. Again, watch out for that mistake that I just made. I didn't write the GCF at the beginning of my work. You should do that, and I should have done it too. Okay, last example. Again, we're looking for the greatest common factor of all three terms. Well, 7, negative 14, and negative 28 all have 7 as a factor. M cubed, m squared, and m to the first all have m to the first as a factor. So when we factor this, we should write 7m, and then we should divide every single term in the original polynomial by 7m in order to fill in what goes in the parentheses. Well, 7m cubed divided by 7m to the first is just m squared. Negative 14m squared divided by 7m is negative 2m. And negative 28m divided by 7m is negative 4. Check it to make sure that it's right by multiplying it back out. 7m times m squared is 7m cubed. 7m times negative 2m is negative 14m squared. And 7m times negative 4 is negative 28m. That is indeed what we started with. So this is the correct answer. Notice that I was a little more cavalier with the divisions here. This is a very familiar process to me. Your teachers should assign, and I will assign, a lot of problems about this, just so that you can get the practice. This isn't a high-level thinking skill. This is an application of several basic ideas that we're putting together to make a more complex skill. Nonetheless, this doesn't get above the application level. So once you get used to it, you should be able to roll through a fairly high volume of work in a fairly short period of time. If you're getting stuck on these, this is not one of those little things that you can go back to class and just fix it. You need to make sure you get some time with your teacher, one-on-one if necessary, or a classmate who's got it, and make sure that you go over this until you've got it. This is a crucial gateway skill, and the rest of the unit on polynomials will make no sense if you do not master this. So please make sure you've got this. Watch the ShowMe over again, practice the practice problems you're given, do extra problems if you have an opportunity to do so. This